Hey guys, we're going to continue our examples for differentiation, and we're going to differentiate this function here, x cubed times e to the x times sine x. You notice that's a product of a couple of functions, so it should bring to mind the product rule, which I'll jot down again. So you remember the product rule is if y is u times v, then the derivative is given by you alternate the derivatives and add them up. So let's try and apply that to this function. What I'll do is I'll pick that as u and pick that one as v. Actually, I'll use a different color. I'll call that one v. Now, so just writing out in full before we continue, that will be u times dv dx plus v times du dx. Just invoking the product rule there. So let's work out each one in turn. The u here is x cubed e to the x. That's easy. The dv dx is, well, we've got to recall what v is. V is sine x, so dv dx, as you may remember, is just cos x. Now let's do the next term, which is v. V is just sine x. But what about this guy? Du dx. Well, u is given by x cubed e to the x. But you might notice that that's also a product of two functions. So to find the derivative, we'll have to use the product rule again. So in other words, let's give it two different names, maybe s and t. And so if you invoke the product rule there, that'll be s dt dx plus t ds dx. And s is just x cubed. dt dx, since t is e to the x, then dt dx is just x e to the x. T there is e to the x. And since s is x cubed, ds dx is 3x squared. So in the end, all I've got there is x cubed ex. Just putting it all back together. So I think we've got all the pieces we need to put it back into our original expression. So let's transcribe that carefully. Plus v, and that was, let's bring that in here, x cubed e to the x plus ex 3x squared. And if you like, you can just simplify this quickly and get, that should be the answer.